So now we're going to talk about quantitative observation. And in chemistry, we use instruments to observe the objects that we study. So we study molecules and atoms, and these, of course, are far, far too small to see. So most of what we see in chemistry, I put "see" in quotes, is through instruments rather than through our eyes. So we use these instruments to measure numerical values and observe the world of chemistry. So if we take an example of a quantitative observation, if we go from Los Angeles to New York, and we measure the distance between these two cities, that's, I think, about 2,248 miles. So on the one hand, we've got this number, 2,248, and we also have units, which are, in this case, miles. So every quantitative observation has a number, units, and also uncertainty. I looked this number up on the web, and I also found the number 2,265 miles. And so there's some uncertainty here, perhaps two different measuring methods, two different groups of people made these measurements, and there's some uncertainty in the measurements. There are really two kinds of certainty or uncertainty in measured values that we want to consider for now. And they're accuracy and precision. And so you've probably heard those two terms used, perhaps even interchangeably. So let's consider now what the difference is between the two. And so we can use a simple sort of thought experiment here. I've got two different dart boards, and we're going to throw some darts at these boards, and we're going to explain what accuracy and precision are and what the difference between the two is. If I start throwing darts at the board and I hit, for example, here, accuracy is how far away that value differs from the true value of whatever we're measuring, or in this case, throwing darts at. So it might be represented by the distance between our throw here and the actual bullseye. So each of these darts has varying degrees of accuracy. They each differ from the bullseye by a certain amount here. Not a particularly accurate dart thrower I am in this case. Precision, on the other hand, is a very different matter. So we might throw a dart and it'll hit here. Throw a second dart, hits very near the first. A third dart hits near the other two, and so on and so forth. So here, all of our darts are falling right clustered in a very small little group here. This is a highly precise bunch of darts, but it's not particularly accurate. Still, the distance between the true value and this group of darts is quite large. So accuracy, again, is the relationship between the measured quantity and the true quantity, represented by the bullseye here. Precision is how reproducible the throws are, how well they cluster together in this case. So this isn't very accurate, but this group is a very precise and reproducible bunch of darts. So if we go to the case where we're throwing and hitting all the time right clustered near the bullseye, we're both accurate and precise. So that's the difference between these two. So let's have a look at a measurement situation. So here we have a ruler, and if we draw a line that we want to measure its length of, and we're going to move this object right so it's matching the edge of the ruler over here on the left, and we're going to read out, to me that looks like we've got something like 4.7 something centimeters, so 4.7, and now I'm going to estimate that last little bit. It might be something like 4.73, but our instrument in this case, as in all cases, has limitations. So all of our measured quantities have uncertainty, and very often we'll overestimate the precision or the accuracy of our observations if we're not careful to pay attention to the limiting features of our instruments. So in this case, I'm estimating this last digit at the hundredths place, and it's a 3. But if I went back and said, you know, it's probably 4.73 plus or minus 0.03, something like that. This is a way of expressing the uncertainty in our measurements, and all of our measurements have uncertainty. So if we go back and quickly review here, we've got quantitative measurements that have 3 parts: the number, the units, and the uncertainty. And we've got 2 types of uncertainty that we want to consider: accuracy, which is how well the value represents or reflects the true value, and then precision, how reproducible our results are.